So this film, this is the Kodiak 2 Robotics department. This should be our third vlog. I don't have a script this time, I'm just winging it, honestly. So we have some cool stuff that came in. We have these, which these are waterproof servos. We didn't actually purchase these directly to put on the ROV, but we did purchase them to experiment with the possibility of having robotic arms, and they're only like $5 a piece, so they're a good test thing. We have other stuff that's come in, and we're very happy about. Servo tester. These are our lights. This is a system that we're going to use to connect things, which basically what it consists of is these are Cat 6 connectors, and so what we can do is we're going to have these in a couple places, and basically we're just going to push our PPM data and other stuff over the Ethernet cables, and so that'll be a simple means of communicating over them. This is the power supply for our OSD module. So yeah, that'll do that. We 3D modeled a prop, and this prop will basically, it'll be our main prop. We will test this prop and then model a couple other ones and see how they work. And so yeah, the 3D models for this will be online. The 3D models for the back of the controller, which this is the controller, and
very expensive one.
No, it's not. It's a Turnigy 9XR from Hobby King. And okay, so what we're going to do is we're going to set a 3D printed module in the back of this, except for our 3D printer isn't working right now. It's a super expensive 3D printer that's a joke.
And it sucks.
Honestly, yeah, it's horrible. So we're trying to get that fixed, and luckily it's still in warranty. I hope it doesn't break off warranty. And so yeah, that'll be the back of this controller, which allows us to interface into the main section on board. We have our FPV screen, and it's just an HD monitor that's 7 inches. And then we have this little camera. It's not a night vision camera, but it is it's a ultra low light camera, so it's really sensitive, and it doesn't have filters for infrared or ultraviolet, so it'll just go into whatever spectrum it has the most light in. This rig over here, could you just pan the camera around for just a second?
Yeah, dog.
Okay, so this is our motor testing rig. Basically how this is going to work is this is going to be upside down in water, and there will be whatever motor that we're testing will rest on here, and so it will press on this scale with how much force it's generating, and then that will allow us to rate each motor. And then we have this one, which this is our crappy one, and then another one that will be doing the voltage and amperage ratings for that test. Let me see, what else do we have? We have our heavy-duty silicone mold release spray, and basically what this stuff will allow us to do is we're using it as a water repellent, because we researched that on the open ROV forums they use this heavy-duty silicone release spray because it keeps the water off of these main motors, and so that you can just submerge the brushless motors underwater. Okay, so we also have some mistakes that we made this week. Those premises were mainly with the Arduino Megas. They have two main circuits. They have the primary power input circuit, which this circuit can handle anywhere between 6 volts up to 20 volts, and that's the circuit that we should have piped power into. But I had made this assumption, and then other mistakes were made by other people, but this controller, because the Turnigy 9XR has the same processor tree as the ones that are in the Arduinos, all those processors, they operate on 5 volts. So we had assumed that the output from this transmitter would also be 5 volts, so that way we could just connect it straight up to the Arduino Mega and it'd be fine. We could pull the data off of it. We already had some code that we had pulled from the internet, and so that reference will be in the description. And on the back of here, there's a PPM pin, a 6-volt pin, a battery plus pin. That was the mistake. We just ignore that. We plugged it into the battery plus pin, so that was a problem. And then there's ground, and then there's antenna. And so the first mistake that we made was that we had just assumed that this operated on 5 volts without even checking. And then the second mistake was not getting a proper pinout diagram. And I'll probably set up a link to the pinout diagram that we got, and then a link to the one that we should have got, because the one that we got, it was incomplete and we really shouldn't have done that. And so we had wired it up based on that, which wasn't a good idea. And then another problem we learned was that if an Arduino stops communicating, figure out why and don't switch it out for the other one, because that's what we did in this situation. Was the first Arduino, I had wired it up and connected it, and it fried it, but there were no signs of it frying. So that was a problem, and so I didn't know, and so what I did was I just switched out for the other Arduino and then fried that one on accident too. And so those are the mistakes that we made, and to solve that problem, we are going to put a diode drop from the PPM pin, which outputs at 6 volts, and we will also be checking all the voltages as we progress through this project, and we will be basically generally being more careful and getting better pinouts and stuff. And so that's what we have learned at this stage. Yeah, I think there'll be a little time lapse after this, and then bye. Thanks for watching.